Hi, Workplace Math 10 students. Today we're going to be doing a video on the very first lesson of the new graphing unit that we're going to be starting. So let's just take a look at what the assignment's going to look like. Excuse me. So if you take a look at this on here, this is what your assignment's going to look like in Google Classroom. It's going to be called G1, and it's an overview of graphing and interpreting line graphs. And so today we're going to be discussing that. So let's get into that. So if we take a look at graphing, basically when we talk about the word graph, what that word means is it means that a graph is a visual representation of data. Now when we talk about data, what does that mean? Well, data is basically numbers of some sort, and when we're talking from a math context. But basically, we have all probably seen a list of numbers that don't make a whole lot of sense to us, or that's just overwhelming, how many numbers and what does it all mean? Well, graphs allow us to quickly see trends or patterns occurring in large amounts of data or numbers. So it can be very useful for us, and we oftentimes will use graphs to try and explain or show trends in numbers we see. Now, when we speak about data, there's really two different types of data that we're usually talking about when we talk about data. One is what we call numerical data. And as the name would suggest, we're dealing then with data that expresses information in the form of numbers. In other words, it's actual numbers we can count. So if we had numbers like 2, 10, 15, 20, 33, 49, that is examples of numerical data. And another example of numerical data that might make a little more sense to you would be if we were to keep track of the number of people that attended the movie theater over a course of a month. That would be numerical data that we could easily graph. Now there's another type of data that we can also graph, and that's what we call categorical data. So categorical data is a type of data that uses groups to group values or information of similar characteristics. So examples of this may be that we keep track of how many people fall within each different type of race within a country. So you may have, English background, you may have African American background, you may have Asian background. So we could keep track of various groups or of people. Same thing with regards to gender, same thing with regards to age. All of these, or even educational level, would be examples of categorical type of data. Now, what we're going to be looking at over the course of the next few weeks is various types of graphs. And basically, there are different types of graphs, but the ones that we're going to be looking at specifically in this course or in this unit are line graphs, and then we'll also be looking at bar graphs, and sometimes known as pie or sector graphs. And then we'll also be looking at pictographs and also tally charts and histograms. So you may or may not be familiar with those terms or what those look like. So let me just give you a quick overview of what those are. So first of all, starting with a line graph. So you can see an example of what a line graph is, and you can sort of see why it gets its name, because it looks like there's a line on a graph. And basically, there are specific points within that line graph that distinguish various spots that it's trying to represent. So in this particular graph, it may be hard for you to see a little bit, but it's basically telling us the population in millions starting in 1985 and going up all the way to the 2005 year. And at every 5-year intervals, there's an actual point on the graph that outlines that. Now, this is just one example of a line graph, but basically line graphs are usually used to represent numerical data, in other words, numbers. And oftentimes, they are best used to show something, how it changes over time. In this case, over years, but it could be over minutes, over days. So line graphs oftentimes are used in conjunction where we're comparing something over a period of time and usually comparing numbers. Likewise, we have bar graphs, and these bar graphs compare things, but oftentimes what they're comparing are things that we call categorical data. So what I mean by that is that in this case here, we have grouped our information into 4 different categories. The categories being 4 different people: George, Alice, Sarah, and Fiona, and we're trying to figure out how many videos each of these people own. So yes, there are numbers attached to this, but basically there's still groups or categories that we're comparing. And we can use a bar graph, but we can also, you may have seen this, and I don't have an example here, where we have multiple bar graphs for the same person. So we may have two different types of comparisons, one being action videos and the other being dramas videos, right? So we could have two bars here as well. In this case, we would have two different types of data sets that we can still show across the same category, in this case being these 4 people. So bar graphs oftentimes used for categorical data. Likewise, pie or sector graphs are also used oftentimes for categorical data. But the difference here is that oftentimes the pie graph is set up as a comparison of a total. And because we have a total, then we can look at how much numbers are in each particular category or section, and we can figure out the percentage that is represented. So with pie graphs, we will often see a percentage of the total number of something represented as percentages and also represented as individual pieces of the pie. So in this case, we have the weekly budget, and we have categories set up that break down the budget into bills, into petrol, which is another word for gas, and clothes and food. And we can see very quickly how much each one is made up. And we can see that clothes and food make up a lot, but that bills make up the most. So that's an example of a pie graph, which in Mathletics is referred to as sector graphs. So then we also have pictographs. So pictographs, as the name would suggest, provides pictures of things. So it's kind of a really nice, nice way to present information. But generally speaking, this data that we have is usually going to represent stuff that is easily counted. So in this case, we can easily count how many apples each of these people have, and we can distinguish them by saying, in this case, that each picture of the apple represents 1 apple. If we had in the graph here that each picture of the apple represents 10 apples, then we would know that Jessica has 20 apples. But in this case, because it only represents 1, we know that Jessica has 2 apples, and John has 4, and Eric has 1. And once again, this generally represents categorical data. In this case, the categories being the 3 different people, Jessica, John, Eric, who all have apples. Now, we also have this concept of tally charts. So oftentimes when we do surveys or we ask questions of people, we will have a various options and they can choose. You may have seen questions that will ask something like, do you agree with this question? And you'll have the answer being strongly agree, somewhat agree, not really agree or disagree, and then disagree or strongly disagree, right? Depending on how you answer that and how many people you survey, you can tally up all those responses and set them into categories and even into what we call meaningful bins. And what I mean by meaningful bins in this case is that we have determined we've asked the question of how many TV sets do you have in your home? And in this case, if we look at this, we have asked 25 people this question, and 25 people have given a response, and the responses vary from 0 TV sets to 4 TV sets in the home. And then basically we just tallied all these up, and once again these tallies mean if we have 4 lines and then a cross through it, that means 5 total. So in this case, there were 5 that said 0 TV sets, there were 6 that said 1 TV set, there were 5 that said 2, there were 5 that said 3, and there were only 3 that said 4. Now, tally charts are very interesting. They're not really graphs per se, but we usually combine this tally chart with something called a histogram, and that's what I'll look at now. So basically what we can see here is that a histogram is a graph, in this case sort of like a bar graph, but it clearly represents categorical data. In this case, the example is age categories from 11 to 20, 21 to 30, 31 to 40, 41 to 50, and 51 to 60, and how many people respond in each of those age categories. So once again, these would be what we call, if we were talking about the tally chart, those meaningful bins that we do. And based on our tallies, if let's say we've figured out that 10 people in the age category 11 to 20 answered this yes, then we would put that in this way into this chart. So once again, these are all various charts that we're going to be looking at, these graphs or charts that we're going to be looking at over the course of this unit. But let's take a look at the very first assignment that you're going to see in Mathletics for this assignment here. And this is what we call line graph interpretation. So if we look at this particular question here, and I'm just going to take this down a little bit so you can see this fully. If we look at this particular question, what we will see is the question says, in what year was the population at its lowest? Now, if I were to look at this, we hopefully can see that the population is expressed on what we call the y-axis. This is the y-axis, okay? And the year of each of these points is what we are called the horizontal or the x-axis. So this is the horizontal axis is the x-axis. Now, if I look at the population, the lowest population, the lowest number here is right here. This occurred right here. And if I were to draw it across, it looks like it lines up right with the number 9. So basically, we're saying 9, and then it's in millions. So 9 million was the lowest population, and that occurred in what year? Well, that year was 1995. So the answer to this particular question, in what year was the population the lowest, would be 1995. Hopefully that makes sense to you. So let me just erase this off here, and then we'll look at the next example here. So looking down here then, the next question is, what was the bank balance on Friday? So in this particular case, sorry, I just will share that with you again. In this particular case, we have Friday occurring right here. This is Friday. How do we know that? Because this point lines up directly underneath Friday here. And when we look at the value that this lines up with, the value looks like it lines up right with 250. And therefore, the balance on Friday must be 250. So the answer to this question would be this here. Hopefully that makes sense to you. Let me just erase that out, and we'll look at the next question, which gets a little bit trickier. They aren't all quite as easy as this. So looking at this, this will be another type of question you will see. This asks, what was the range of the salmon population? So we're not just asking what the salmon population was for a particular situation, but we're asking for the range. And this word range actually means what is the difference between the highest number and the lowest number. Now, if we look at this then, if we understand what range is, which is the difference between the highest and the lowest number, we obviously need to know what the highest number was, and we need to know what the lowest number was. So looking at this, this is the highest number in 2001, and the lowest number occurred in 2003. Now, if I look at this, it's kind of hard to tell exactly, but it looks like this point is halfway between 90 and 100,000. So that would suggest 95,000. Okay? Now, if I then look at the lowest number here, this looks like it sort of falls between the 10,000 and 20,000, almost right in the middle, and halfway in between 20 and 10,000 is 15,000. So if I were to take the difference between the highest number, which is 95,000, that's the highest population, and the lowest population, which was 15,000, I just put that into my calculator. So I'm just going to stop share here and then switch to my calculator here for a second. So I'm going to put in the number 95,000 minus the 15,000, which is the lowest number. And what we end up with is a figure of 80,000. So this is why then this would be our answer. So our answer that we're going to want to choose is 80,000. So this would be our value right here that we would put, would be 80,000 here. Does that make sense? So let's take a look at our last question here. So this is very similar, but it doesn't use the word range anymore. It just says how much higher or lower is the population in 2005 compared to 1990. So we are looking at two different points. So one is 2005, which is right here. And then we're also looking at 1990, which is right here. And what we need to do is we need to look at and determine what this is. And once again, this is in millions, but I'm not going to write the word number of millions. I'll just write the amount of millions. So this looks like it's between 14 and 16. So that would be 15. So it's 15 in 2005. And now it looks like it's between 6 and 8 here for 1990. So that would be suggested this is 7. So 15 minus 7, we could put into our calculator, but we could also hopefully do that in our head. So that's going to be 8. But it's not 8, it's actually 8 million, right? It's 8 million. And has our population gone higher in 2005 compared to 1990 or lower? Well, in this case, it is higher than this, so it would be at 8 million higher, not 8 million lower. So the answer to this question would be this, 8 million lower. Hopefully that makes sense to you. So based on that, you should have enough to go with to try this first graphing unit Mathletics assignment. So give it a try, please. And if you have any questions, please do not hesitate to ask. Thanks for watching.